Okay guys, problem number one, answer right here. Okay, so let's go ahead and put this is out of 9 points. Okay, and letter A, find the area of R. Just you get a point for your integrand. Okay, a point for your integrand. So that's a point right here, and then a point for your answer. All right, go ahead and grade that. Okay, so this is a top minus bottom rule, guys. So the area, that's the top function, the sinusoidal, and the bottom function is the cubic function there. Okay, so just put 2 out of 2, or you can put how many missed. Here, you've got the line y equals -2, intersects with there. I had a calculator app on my phone. I thought I lost my graphing calculator, but I didn't. Here, when I did the intersection on the calculator, this is what I got. You save all the decimal places. Here, when I did the intersection on the calculator, this is what I got. You save all the decimal places. Store, like we did, and then do your math 9. So you do your math 9, you store it, and you do it, and then you'll literally, it'll be FNINT. Well, I'll show you on the calculator. All right, I've got it stored already. Okay. So math 9. I'm just gonna put it in. I've changed my y, but I'm just gonna put it in bars. Y sub 1, comma x, comma a, comma b. Okay, so that's how you're gonna do your integrals once you store an a and a b. And what you have to do is you have to write it down and then store it in your calculator, but you have to store all the decimal places. Okay, store all the decimal places. So you get about that right there, but when you minus the bottom one, you get there. Okay, and if you're 100th or off or so, it's okay, because the AP readers will know whether or not you stored it like this, or there's a separate way of storing it. We won't go over that. We don't necessarily need to do that, but they'll give you credit for both. All right. All right. So if you're a couple hundredths off or a couple thousandths off, I think it's okay. All right. Right here. See if I can pan out. All right. Right here. Okay, so those areas of the squares right there. Here's a square. Okay, the side of the square is the top function, sine pi x, minus the bottom function. Okay, so how do I find the area of a square? Well, that's side squared. Side equals top minus bottom. Boom. So the volume of the solid is equal to that right there. So, okay, my bad. Up here, when you graded this one, you got a point for your this point for your top your interval, point for your limits of your integral, and a point for the right integrands, and then a point for the answer. So kind of like 1, 1, and then 1, 3 out of 3. Okay, so here now on this one, this is out of 2. Okay, this is out of 2, and I'm gonna have to cover up A and B. There we go. Just kind of do it that way. Okay, alright, that'll work. So here, stay. Here, this is out of 2. You get a point for your integrand or equivalent variation, okay, squared, equals your answer. So a point here, a point here. Now the last one was tough. What you had to recognize was that the height is 3 minus x, basically, the depth of the water anyway. So basically what you're going to do is you're going to be adding all these little rectangles. Well, at the beginning it's 3 minus x. The x is small, so the depth is approximately 3, or the height, if you will. Okay, the height is approximately 3. Here at 1, x equals 1, well, the height is 3 minus x, so the height is approximately 2, or the depth, if you will. And then as it goes on, it gets less deeper, it gets shallower as you go on. So anyway, it's just a cross section, volumes of cross sections. So you're just integrating rectangles, so you're adding up rectangles. Your cross sections are rectangles. So you integrate the A, boom, you got that. Your base is all this, your height is this. So you get a point for here, your base, here, your height, for integrating the base or integrating the height, and putting them together, yes, and then a point for your answer. So you got 3 out of 3 right there, okay? Alright, you can pause it, you can rewind it, do what you gotta do. Alright guys, moving on to the next one right here, okay? Alright, next we have, alright, waiting in line, okay? So here's a little chart that we were looking at. Alright, so we want to know the rate of people changing, and well, we're guessing at 5.5. Well, 5.5 is right here between 4 and 7. So if we want to know the rate of people changing, that's a change in people over time. That's the same as the change in y over the change in x. Okay? So we have to know that, and this is one of those things you just have to know, that it's the slope formula. Slope formula is y1 minus y2, and this is really your y, this is your x, over x1 minus x2. So if you've got a numerical thing, to find a numerical derivative given a table, you might have to like guesstimate using the slope formula, which is okay. We know the derivative is the function whose slope is whose output is the slope of the tangent line, but you can get the rate of change just with a slope formula, but it's not exact. So I guess I should put approximately. So this I'm going to give you out of 2, okay? Just using the difference quotient or the slope formula, okay? And your answer. So 1, 1. Okay, next. Now B, for first 4 hours, all right? We wanted to do 3 trapezoidal subintervals, okay? Well, here's the area of a trapezoid. So Riemann sum, please turn it down, Lennon. Riemann sum, we're just adding up these trapezoids, right? So basically, our first trapezoid, y'all can see the chart. You should be following along on the chart. There's our chart. Alright, our first trapezoid is just from 0 to 1. But here are the heights, right? Because you got to remember, or the heights, these are the heights, but they're also the bases. Okay? Because that trapezoid is slanted. These two are parallel. If you draw the graph, if you draw like this graph, you'll be able to see that those are, you know, the bases, base 1 and base 2. So add them, do half of that times the height. Well, the difference in the x values is the height. So such as this difference will be 2, right here. Okay. All right. Here, basically, you have, you basically are getting out of 2 right here again. Okay. I believe so, because all you're doing is you have to show that you're adding up trapezoids. You have to use the trapezoid formula, basically. And yes, the trapezoid formula, you have to memorize it. I do not think that you'll be given the trapezoid formula in the AP exam. So here you go. For showing individual areas added up, like showing this, not this, but this. Like you have to show it all out. If you just did this or something equivalent, that's okay. But on the AP exam, write out the entire formula and a point for your answer, 2 out of 2. Okay? Alright, pausing. Deep breath. Alright, here we go. Next one. Alright, so Yeah, on the calculator portion, there's not a lot of calculator use, and I'm sure you're seeing that trend by now. Um, they want you to be able to know calculus, and the calculator don't know calculus. Only the person using it. So here, what we wanted to find is how many times the rate of change of people waiting in line is 0. Well, that's the rate of change is the slope basically, and the slope is the derivative. So we're trying to find out how many times the derivative or the slope equals 0. So in order to, if we don't have an equation to set equal to 0, we just look at where's the slope positive and where's the slope negative. To go from a positive number to a negative number, first you have to hit 0. 0 occurs once there, 0 occurs twice there, and 0 occurs the third time there. But you can't just use this as your reasoning. You have to, so you get a point for here 3 occasions, all right, and a point for the justification. Okay, and you could say the derivative changes sign 3 times on 0 to 9. You could say a lot of things for the justification. So I guess this one would be out of 2. Okay. Right, not too many points here. That's okay. Alright, so this would be out of 2. Alright, now the last one, alright, they wanted to find out how many tickets were sold. Well, don't get confused and tricked into using this information, because this is the number of people waiting in line, okay? The number of people waiting in line. So it's not, this has nothing to do with tickets sold. The function given in the problem, which was, I don't remember exactly what it was. Let me see. Yeah, it was 550 t e to the negative t divided by 2. That's the change in tickets sold, r prime of t, or sorry, r of t. So it's kind of like the derivative. R of t is the change in tickets. Well, you gotta start thinking when you see the word "the change in," because that means it's basically the rate of change. So in this case, it really is a derivative. Well, how do you get the original number of tickets? If you have the derivative, you take an integral. So we're gonna make this one out of, we'll make it out of 3, just so we can hit our mark of 9. Alright, so this is, your intervals is going to be a point, your integrand is going to be a point, and this or equivalent, and your answer is going to be a point. So 3 out of 3. There you go. And go ahead and grade it. Alright, you're on your honor. Write the number missed at the top. This is out of 9. Let me double check. 2, 4, 6, 9. Yes, it is. Alright. And come see me before or after school to look over it if you have any questions. Alright? Take care.